Hello everybody and welcome to today's lesson on variation. Our objective today is we will identify, create and solve real-world problems involving inverse variation, joint variations and a combination of direct and inverse variations. So let's start with direct variation. Direct variation you have already learned about in Algebra 1, and it is a linear relationship and it is based on the equation y is equal to k times x, and k is a very important thing here, and sometimes people also call it a, k or a, and that is our constant of variation. Please note that k is in the same position, even though it's a different letter, it's in the same position as m, the slope that you have known since we talked about linear equations. Remember, slope-intercept form, y is equal to mx plus b. Here we're using k, it's a different letter, but it has the same purpose and the same effect on our function. It's essentially the slope of the line. And the other very important part I want you to realize is, again, comparing to slope-intercept form, we have no b. There is no b in the back of our equation. In other words, b is 0. And that means that any direct variation equation or the graph of that always goes through the origin. Always. Every direct variation equation has a line that goes through the origin because b is always 0. Okay, let's look at a couple of examples. I'm going to do the first one, and then I would like you to try and do the second one yourselves, and then compare your work with my answers. X and y vary directly. That is always a key for us to realize. When you hear that wording, then we need to work with direct variation and with our equation y is equal to k times x. And very often we're supposed to find the constant of variation. Find the constant of variation k to write the equation relating y and x. Then find y when x is 4. So starting with our equation y is equal to kx, we can plug in the values that we are given. 1/2 is equal to k times 5. If we divide both sides by 5, or in this case more easily even multiplied by 1/5 by the reciprocal, we end up with 1/10 is equal to k. And that is our constant of variation. And if the constant of variation is 1/10, then our equation is y is equal to 1/10 x. And so if x is 4, then y has to be equal to 1/10 times 4, or 4/10, which is the same as 2/5. Y is equal to 2/5 when x is equal to 4. So always start off with our equation y is equal to k times x. Plug in the numbers that you're given to find k, and then use that to create your own equation and use it to find more values of y if x is given, or of x if y is given. Now stop the video and go ahead to the next one yourselves, and then compare your work with my answers. Hopefully you arrived at the same answers. Y is equal to k times x. If we plug in the numbers 6 for y and -3 for x, we get k is equal to -2. Plugging that into our equation, now for this direct variation, the equation is y is equal to -2 times x. And if x is 4, then y, in this case, needs to be -8. All right, let's move on to joint variation, and that is something new. A joint variation is a product of two or more direct variations. A product of two or more direct variations, and the equation is y is equal to k times x times z. So we have at least one more variable. In this case, it's z. K is again our constant of variation, and also in terms of how do we word this, how do we describe this, we usually say y varies jointly with, or sometimes people also say as x and z. In our examples, the variable y varies jointly with x and z, and as we said, sometimes you also see this with as. Use the given values to find an equation that relates the variables, then find y when x is 2 and z is 8. So here we have two inputs that can influence the output y. So starting off with our equation, y is equal to k times x times z. We're now going to plug in all the numbers that we have. 144 is equal to k times 8 times negative 54. Using our superior multiplication skills, or maybe our calculator, we can say that 144 is equal to negative 432k. Now let's divide both sides by negative 432, and we get negative 1/3 is equal to k. So here goes our equation. Y is equal to negative 1/3 x times z. Well, then y is equal to negative 1/3 times 2 times 8. Y is equal to negative 1/3 times 16, or in other words, equal to negative 16/3. Okay, again, stop the video and do the next one yourselves, and then compare your work with my answers. Hopefully you came up with the same answer. 24 is equal to k times 4 times 3. Multiplying this out, we get 24 is equal to 12k. Dividing both sides by 12, we get 2 is equal to k. So our equation is y is equal to 2 times x times z. Plugging in 2 and 8 for x and z, we get y is equal to 2 times 8, or in other words, y is equal to 32. And that is your answer. And now let's move on to inverse variation. Inverse variation is not new to you. Again, that is something that has also been learned in Algebra 1. The equation goes y is equal to k divided by x. In other words, our input, our variable x, is in the denominator, and that has certain consequences, and that also is a good introduction into the rational functions we're going to be discussing in this unit. The first and most important implication is that x can never be 0, right? Remember, we can never divide by a 0, so x can never be 0. And when we graph an inverse variation equation, we get a curve that looks like this. It is also called a hyperbola. And I want you to spend a minute thinking about what happens as x gets closer and closer to 0. It can never get to 0 exactly, but it can get closer and closer. And what happens to your function and to your graph if that happens? Okay, so now let's look at some examples again. X and y vary inversely. Now that is how it would be worded in a problem like that. And again, we need to find the constant of variation, k, to write the equation, and then we need to find a particular y for a given x. In this case, x is 3. So, starting with our inverse variation equation, we now know that 1/8 has to be equal to k divided by -32. So let's multiply both sides by -32. And we get -4 is equal to k. So that means our equation is y is equal to -4 divided by x. And if x is 3, therefore y is equal to -4 divided by 3. And we can't really simplify this any further. So this is our answer. And again, now go ahead, stop the video, do the work for example number 2 yourselves, and then check back in and compare your work with my answers. Plugging in the values, we get 9 is equal to k divided by 6. Multiplying both sides by 6, we get 54 is equal to k, our constant of variation. Therefore, our equation is y is equal to 54 divided by x. Plugging in 3 for x, we get y is equal to 54 divided by 3, or in other words, y is equal to 18. Good job, you guys. Now let's move on to some real-world examples and examples where different types of variations are combined. Our first example, the number of songs that can be stored on an MP3 player varies inversely with the average size of the song. A certain MP3 player can store 2,500 songs when the average size of the song is 4 MB. Write a model that gives the number n of songs that will fit on the MP3 player as a function of the average song size s in megabytes. And then figure out how many songs will fit on that very MP3 player if the average song size is 5 MB or if it's 3 MB. So let's start off with our equation. The number of songs varies inversely with the average song size. So n is equal to k divided by s. And we are told that there are 2,500 songs that can be stored if the song size is 4 MB. So 2,500 is equal to k divided by 4. Now let's multiply both sides by 4. We get 10,000 is equal to k. And you can also think about what is that 10,000 really. So our equation is n is equal to 10,000 divided by s. And now let's find the different values. What is n if s is equal to 5? Well, then it's going to be 10,000 divided by 5. In other words, then n is going to be equal to 2,000. And what is n if s is 3? Then it's going to be 10,000 divided by 3. Now 10,000 cannot be divided by 3 without a remainder, so we're going to say approximately, n is approximately 3,333 songs. And that's our answer. And looking at our answers, It does make sense, right? If the songs are longer, then we can get less songs saved on that drive, and essentially the 10,000 is the storage capacity in megabytes, and the longer the songs are on average, the less songs you can store on that MP3 player. Okay, let's move on to the next example and the last one for today. The number of vibrations per second, the pitch of steel guitar strings, varies directly as the square root of the tension and inversely as the length of the string. If the number of vibrations per second is 5, when the tension is 225 kilograms and the length is 0.6 meters, find the number of vibrations per second when the tension is 196 kilograms and the length is 0.65 meters. Phew, lots of information in this problem, so let's just again start by figuring out our equation and take it from there. First we have to assign some variables. So the pitch I'm going to call P, then the square root of the tension I'm going to call T for tension, and then we have the length of the string and I'm going to call that L. I'll put the L here too so it's better visible. So here goes our equation. P varies directly, but first of all we do have a constant of variation here somewhere, and P varies directly as the square root of the tension. T is our tension and it varies directly with the square root, so let's make that a square root. Directly means it multiplies the constant of variation, but then it varies inversely as the length of the string, so L, our variable L, goes into the denominator. And here is our equation, and the next thing we do is we plug in the numbers that we were given in the one case. So the pitch is 5 when the tension is 225 kilograms, so the square root of 225, and that's divided by 0.6, which is the length of our string. Here's our equation. Now first, let's go ahead and multiply both sides by 0.6, and we get 3 is equal to k times the square root of 225. Now the square root of 225 is 15, so we're talking about 3 is equal to 15k. Divide both sides by 15, and we now know that k is equal to 1/5. Circle that for our first partial result. That means our equation is P is equal to 1/5 times the square root of T divided by L, and you could also put the 5 of our fraction into the denominator together with L, makes no difference. Okay then, let's plug in our numbers for example where the tension is 196 kilograms and the length is 0.65 meters. P is equal to 1/5 times the square root of 196 divided by 0.65, and as you put that into your calculator you will get a result that said that this is approximately 4.31, and that is, remember, vibrations per second, and the more vibrations the higher the pitch, so this pitch of 4.31 is actually lower than the pitch in the previous example. The pitch was 5. Okay, so much for this, and I will see you in class.